Let's talk pH. What is pH, you ask? Well, it's like a secret code that tells us whether something is acidic, basic, or neutral. Acids, like our tangy friend lemon juice, have a low pH. They taste sour and can make things like milk curdle. On the other hand, bases like baking soda have a high pH. They taste bitter and feel slippery. Remember that soapy feeling? That's a base at work. Now the pH scale goes from 0 to 14, with 7 being neutral, like pure water. Lower numbers mean more acidic and higher numbers mean more basic. Pretty simple, right? pH indicator. Removing stubborn stains and odors. Section 5. The Browning Bonanza, Maillard and Caramelization. Ever wondered why bread turns brown and crispy when toasted? It's not just about the heat, it's a fascinating chemical process at work. Or why meat develops that delicious crust when seared. That mouth-watering aroma and flavor are the results of complex reactions. That's the magic of the Maillard reaction and caramelization. These processes transform the ordinary into the extraordinary. The Maillard reaction happens when sugars and amino acids in food react at high heat. This reaction is responsible for the browning and complex flavors in many cooked foods. This creates hundreds of new flavor compounds, giving cooked food that rich, complex taste. It's what makes a simple piece of meat or bread so much more enjoyable. Think of the savory aroma of roasted coffee beans. That deep, inviting scent is a direct result of the Maillard reaction. Or the meaty smell of grilled steak. These sensory experiences are enhanced by the Maillard reaction, making our food not just taste better, but smell irresistible. Caramelization, on the other hand, involves only sugars. It's a simpler process but equally important in the culinary world. When heated, sugar molecules break down and rearrange, resulting in that beautiful brown color and intense caramel flavor. This process is what gives caramel its distinctive taste and texture. Imagine the sweet, nutty notes of caramelized onions. This transformation elevates the humble onion to a gourmet ingredient, or the glossy sheen of creme brulee. The caramelized sugar on top adds a delightful crunch and a rich sweet flavor that makes this dessert a sauce that's perfect for sandwiches, salads, and dips. Bacteria and yeast that transform food in amazing ways. Take bread, for example. These microbes are nature's little chemists, working tirelessly to break down sugars and produce gases and acids that change the texture, flavor, and nutritional profile of the food. When we add yeast to dough, it feeds on the sugars in the flour and releases carbon dioxide gas. This process is called fermentation, and it's what makes the dough rise. The yeast cells consume the sugars and produce carbon dioxide and alcohol as byproducts. This gas creates bubbles in the dough, making it rise and giving bread its airy texture. The alcohol evaporates during baking, leaving behind the delicious, fluffy bread we all love. The process not only makes the bread rise but also develops its flavor and texture. Yogurt is another example of fermentation. It's made by adding specific strains of bacteria to milk. These bacteria ferment the lactose or milk sugar into lactic acid. In this case, bacteria convert lactose, which is milk sugar, into lactic acid, giving yogurt its tangy flavor and thick texture. The lactic acid acts as a preservative, extending the shelf life of the yogurt while also providing beneficial probiotics that are good for your gut health. Want to see fermentation in action? It's a fun and educational experiment that you can try at home. All you need are some basic ingredients and a little bit of patience. Try this simple experiment. Mix warm water, sugar, and yeast in a bottle. The yeast will start to feed on the sugar, and you'll see bubbles forming as it produces carbon dioxide. Attach a balloon to the top. This will capture the gas produced by the yeast. As the yeast ferments, the balloon will inflate with carbon dioxide gas. This simple experiment is a great way to visualize the power of fermentation and the incredible work of microbes. So, next time you enjoy a slice of bread or a spoonful of yogurt, remember the tiny microbial marvels that made it possible. Section 8. Heat and transformation. Cooking up chemistry. Heat is like a magic wand in the kitchen, transforming ingredients in countless ways. One of the most important effects of heat is protein denaturation. Proteins are like building blocks that give food structure. When heated, the bonds holding these proteins together break down, causing them to unwind and change shape. This is called denaturation. A perfect example is cooking an egg. When we heat an egg, the proteins in the egg white denature and coagulate, turning from clear and runny to white and solid. The yolk also undergoes changes, becoming thicker and creamier. Understanding how heat affects proteins helps us cook food to the perfect temperature and texture. Imagine biting into a sphere of mango juice that bursts in your mouth, or a tiny ravioli filled with liquid pea soup. These innovative techniques allow chefs to play with textures and flavors in ways that were previously unimaginable. Molecular gastronomy opens up a world of possibilities, pushing the boundaries of traditional cooking. It's not just about taste, it's about creating an experience that engages all your senses. From the visual appeal of a dish to the unexpected textures and flavors, every element is carefully crafted to surprise and delight. So there you have it, a whirlwind tour of kitchen chemistry. We've only scratched the surface of what's possible with molecular gastronomy. The next time you dine out, keep an eye out for these innovative techniques and appreciate the science that goes into creating such extraordinary dishes. From the tangy power of acids to the microbial magic of fermentation, there's a whole world of science happening in your kitchen every day. Each ingredient and technique has a story to tell, a chemical reaction that transforms it into something delicious and unique. Now that you know the secrets, go forth and experiment. Don't be afraid to try new things and push the boundaries of your culinary skills. Whether it's a simple spherification or a complex multi-course meal, the world of molecular gastronomy is at your fingertips. Try out these simple experiments, get creative with your cooking, and most importantly, have fun exploring the delicious world of food science. The kitchen is your laboratory, and the possibilities are endless. Happy cooking!